Today we're going to look at more quadratic word problems. We've learned so far how to solve by factoring and solve by formula. We've also learned how to find maximum and minimum by completing the square. So when we look at our word problems today, we are going to talk about how you know when to solve and when to complete the square. So our first question here says, Chantal wants to construct the following using 300 centimeters of wire. What dimensions would she need to use to enclose a total area of 1,728 centimeters squared? So the important pieces of information I see here are that we have 300 centimeters of wire and that it needs to enclose a total of 1,728 centimeters squared. So when we're doing a word problem, the first thing we need to do is start with x. We need to let x be something in our question, and then we try to figure out what our second thing is. So in this question, it is asking about dimensions, and dimensions mean length and width. So in this question, I'm going to let one of the things, either length or width, be x, and then we will try to find an expression for the other part. So I am going to let something be the length, and let something else be the width. Now the choice is yours, but I'm actually going to use the diagram to help me figure out which one I should let be the length and which one I should let be the width. So when I take a look at this enclosure, there's enough wire to go around the outside plus the 4 partitions in the middle. So if I were going to build this out of wire, I would need 2 length pieces and 1, 2, 3, 4, 5, 6 width pieces. When I'm doing my let statements, whichever one I have more of is the one that I usually let be x, just because it tends to work out a little bit better. So in this case, I am going to let x be the width, since I had more width pieces, and then I'm going to try my best to figure out an expression for the length. So to figure out the length part, I am going to take a look at my diagram. I know that that 300 centimeters of wire has to use up all the different sides and middle pieces of my picture. So if this is a length, this is a length, we've got a width, 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 and width. So all together to build this shape would take 2 lengths and 6 widths. So 2 lengths plus 6 widths all together would use 300 centimeters worth of wire. Okay, we know that we're going to let x be the width, so this really is going to be 2 times the length plus 6x equals 300. And now all I want to do is come up with an expression for the length. So I'm going to rearrange the equation to get L all by itself. So I will start by taking the 6x to the other side by subtracting. So I get 2 lengths equals 300, take away 6x. And then we're going to divide everything through by 2 to get that the length is 150 minus 3x. So I'm going to let the length be 150 minus 3x. All right, the other piece of information in the question is the area. It has a total area of 1,728 centimeters squared. So I'm going to start an equation for area. Area of a rectangle, which is what this is, even though it's broken into smaller pieces, the total area is still just going to be found by doing length times width. So I'm going to write area equals length times width. And then I'm going to substitute in my length, which is 150 minus 3x, and my width, which is just x. And I do actually know the area. It tells me that the area is 1,728 centimeters squared, so I'm going to substitute that in. Now, regardless of whether this is a solving question or a max-min question, we will always need to expand this, multiply it out to collect up like terms. So I am going to multiply the x into the bracket. So I get 1,728 equals x times 150 is 150x. X times negative 3x is negative 3x squared. Now, to do any of these questions, you do always want all of the terms to be on one side. So I either need to move these two terms over to the left, or I need to move the 1,728 over to the right. Now, since my x squared is negative, I always like it when it's positive, so I think I'm going to move the two x terms over to the left. So I end up with 3x squared minus 150x plus 1,728 equals 0. Now this is the tricky part of the question. This is where you have to decide what you want to do. Should you solve by factoring? Should you solve by quadratic formula? Or should you complete the square? So we complete the square when we're trying to find a maximum or a minimum value. And you want to look for things like highest, lowest, biggest, smallest. They're things that I call EST or EST words that will give you a clue that you should complete the square. When you want to solve, you're going to usually be given the product in the question. So it'll tell you the product, it'll tell you the sum of the squares, it will tell you what the total area is. You'll have a number to substitute in on both sides of the equation, and you'll end up with an equation that's equal to 0. So when you're solving, you should have had a number to sub in, and you should end up with an equation where it equals 0. So in this question, it didn't ask for the maximum area, didn't ask for the biggest or the largest area. It just wants to know what is it when the area is 1,728, which means this is actually a solving question. So we have a choice here. We can either solve by factoring, or quadratic formula. Okay, and it's your choice, whatever you like the best. I am looking at those numbers and they are fairly large. I could try to factor, but I think it might take me a while to find the numbers that work there. So I think that I might try using the quadratic formula. So I'm going to start by listing what A, B, and C are. So A is 3, B is negative 150, and C is 1,728. And then I want to always write out the formula. So x equals negative b plus or minus square root b squared minus 4ac divided by 2a. Hey! All right, then all we need to do is substitute in, let's just zoom in a little bit there. We're going to substitute in our values for a, b, and c. So negative b, we have negative 150, negative negative makes a positive, so positive 150 plus or minus, that's what gives me those two answers for my quadratic. B squared, so negative 150 squared. Make sure you put in the brackets, especially if you have a calculator where you see the things you type in. You want to make sure you have those brackets there or you might not get the right answer on your calculator. Minus 4 times 3 times 1,728. And that is all divided by 2 times 3. All right, so I'm going to calculate what's under the square root and simplify what's in the denominator. And I'm going to need my calculator for that. So I want to do negative 150, and I'm going to do brackets there. So negative 150 squared minus 4 times 3 times 1,728. And I end up with 1,764 So now what we're going to do is we're going to calculate what our two answers are. Sometimes we do exact values, and that's a really good thing to do when you just have a quadratic question that says solve. But when we're doing a word problem, it really does make more sense to have a decimal if it comes out to be a decimal. So we are actually just going to figure out what's here. So we're going to do 150, and we're going to split it up into the plus and the minus. We'll do 150 plus, and then 150 minus. So 150 plus the square root of 1,764 over 6, and 150 minus 1,764 divided by 6. Now the square root of 1,764 is 42, so that worked out nicely. So we're going to get 150 plus 42 divided by 6, and 150 minus 42 divided by 6. Okay, 150 plus 42 is 192, and if we divide that by 6, we get 32. 150 minus 42 is 108 divided by 6 is 18. So I ended up with two answers here. I have 32 and I have 18. So what you want to do at this point is you really do want to go back to the question and look at what x was. What did we let x represent? And if I go back up to the top, we let x be the width. So that means the width could be 32, which is an okay number. It's positive, so that would be okay for our width. Or the width could be 18, which is telling me that there are two entirely different ways that we could build that structure out of wire. So what we're going to do is figure out if the width is 32, what would the length be? If the width was 18, what would the length be? And to do that, let's just zoom back out a little bit. I want to go back up to my let statements and see what I let the length be. We let 150 minus 3x be the length. So since I have my two different numbers, we're going to try doing 150 minus 3x for both of them. So for the 32, if the width is 32, then the length is going to be 150 minus 3x, or 3 times 32. Now 150 minus 3 times 32, 3 times 32 is 96. 150 take away 96 is 54. So one way we could build it is if it was 32 centimeters wide and 54 centimeters long. Okay, the other possibility is if the width is 18, so the length is going to be 150, take away 3 times 18. 3 times 18 is 54. 150, take away 54 is 96. So we have two possibilities. So therefore, the dimensions are 32 centimeters wide and 54 centimeters long, or there's actually two ways to do it, 18 centimeters wide and 96 centimeters long. And there we have it.